Hello everyone, my name is Curly May H. Juan, and today I will be discussing an essential topic in engineering, which is what we call reliability in engineering system. In this presentation, we will cover various aspects of reliability, including analytical methods, components configuration, reliability program, regulatory authorities, and how organization ensures system dependability. As we all know, reliability is crucial about industry, especially in our field, which is engineering, aerospace engineering exactly, to healthcare, automotives, and manufacturing. Without reliability, we risk safety hazards, financial loss, and operational efficiencies. By understanding this principle, engineers and organizations can design product and test it from time to time. I'll be discussing 7 topics: the analytical system reliability, components configuration, reliability programs and implementation, reliability control system, investigation of reliability alert. That's it. That's the main 7 topics that I'll be discussing one by one. Let's start first with the analytical system reliability. Analytical system reliability refers to the mathematical evaluation of a system's ability to perform its intended functions under a specific condition for a given period. It also involves using probability theories, statistics, and engineering principles to predict failure rates, mean time between failure or the MTBF, and overall system dependability. There are common statistical methods that we will be using. We might know some of them already, but since I'll still be discussing the common statistical methods. There are 6 common statistical methods mentioned here. The first one is the mean time between failure, or what we call the MTBF, mean time to failure, or what we call the MTF, system reliability model, failure mood and effect analysis, fault tree analysis, or what we call the FTA, reliability block diagram. Let's give an example sa mean time between failure, or what we call the MTBF. Let's say if a machine operates for a 1000 hour, like let's say there are 24 hours in a day. If we compute it, if we divided it to 1000, let's say there will be 41 days, if I am not mistaken, let's say 41 days. Since we all know na machines won't work 24 hours, let's just give it to the fact that let's just say 12 hours. 12 hours divided by 1000, let's just say 81, 82 or something. See, we can use it for at least 82 days. That's what we call the MTBF. Let's explain the failure mood effect analysis. It is also used in automotives and aerospace industry to identify the weak points in design before production. Before they start its production, they must know first the possible issues that they could encounter. In order to do that, they will try the failure mood and effect analysis to know whether they must continue it or move to another manufacturer or something. Let's say reliability block diagrams, or the RGD. It visually represents components reliability within the system. Okay. The fault tree analysis, or what we call the FTA, it it helps us assess how different failures contribute to a system. Oh, it's just the same thing as failure mood analysis, so they're more likely to be the same. Okay, mean time to failure. Mean time to failure, it's knowing, it's the same thing in the mean time between failure or mean time to failure. It is somehow similar lang. Okay, the next one is the configuration, components configuration. In reliability engineering, components configurations refers to how different components are arranged within a system to affect overall system reliability. There are three main types of components configuration. The first one is the series configuration, the second one is the parallel configuration, and the third one is the series parallel mixed configuration. But since I'll only be tackling about the series and parallel lang, so see, two types of component configuration. The first one is the series and the second one is the parallel. So series configuration, all components must function for the system to work. If one component fails, the entire system fails. So sa series, parang like everything, example, let's just say na you are 5 in a group, there is 5 person in this group, and then if one person didn't comply the things that he must do or she must do, then the rest of the work will fail. Yes, fail. Unlike parallel configuration, the system works as long as at least one component function. So in this case, let's just put an example na parang the leader carried the members. So in this case, they will all pass because one of the leader's workman, unlike this series configuration, whereas all of the members must work, but if one person doesn't work, then they will all fail. So that's the two types of configuration. So reliability programs and implementation. A reliability program has a structured approach ensuring that the system products or processes perform in an intended function without failure over a specified period. It integrates engineering testing, maintenance practice to enhance dependability, reduces failures, and extend operational life. So let's put it in a scenario. An airplane wants to improve the reliability of its fleet to minimize delays, ensuring the passenger safety. So here is my implementation. So the first one is, of course, reliability planning. In this part, we will define our goals, our metrics, or for example, ng metrics is the what we call the mean time between failure or the MTBF, as what I've discussed earlier in the analysis, right? And then the methodology. So in the second part, which is the design for reliability or the DFR, it incorporates reliability principles into product system design. For example, fault tolerance or redundancy. So the next step, which is the 3, is what we call the failure mood and effect analysis or the FMEA, right? So the FMEA identifies potential failure points and mitigates risk. So number 4 is accelerated life testing. It simulates extreme condition to estimate lifespan. So the next step is the preventive and predictive maintenance. Wrong spelling. Oh my god. I saw that my spelling in the preventive is wrong. Okay, I'll just edit it later. So in this part, it uses schedule inspection and data analysis to prevent failure. It is usually common in smaller aircraft or also the bigger aircraft, right? When you or having your OJT na there is 50 hours pre-flight check or the flight check, like you need to input all the datas, whether it was just preheating the engines. So the 6 is the root cause analysis. So RCA defines diagnosis failure to improve design. And then the 7 is the reliability data collection and analysis. In this part, it uses statistical tools for failure prediction. So the next part, or the last part, which is the continuous improvement, so implements feedback loops for ongoing enhancements. So need for reliability program. Structured reliability program is essential to it reduces failures at maintenance cost. So as we all know that failure can cost us a lot of money, man, especially in aviation industry, since every part of the aircraft is not like mura. It's like very expensive, man, right? So it also enhances safety and critical application. Of course, since we're dealing with aircraft, we're also dealing with the lives of the people. So we need to really maintain the aircraft to ensure the passenger safety as well, the pilot safety, right? So it also ensures compliance with the industry standards. So of course, in the aviation industry, we do have lots of standards, especially in the ICA, ICAO, like that. Okay. Second, challenges in implementation. High initial cost. As what I've said, it is really high, like it's quite expensive. And then difficulty in predicting failure modes accurately. Resistance to change with organization. So let's talk about reliability programs and implementation. A reliability program is a structured approach ensuring that the system, product, or process perform their intended functions without failures over a specified period. It integrates engineering, testing, maintenance, and practices to enhance dependability, reduces failure, and extend operational life, right? So, reliability programs must be embedded from the start design stage to the final product. For example, automotive company integrates failure testing in the early prototypes. One of its example is car manufacturers conduct crash tests and accelerated life tests on airbags, ensuring they deploy correctly over years of usage. So, these are the regulatory authorities. So, in Aerospace Department, we have the FAA or the EASA. So, in the automotives, they do have NHTSA. In the healthcare, we have the FDA ICE 606001. So, let's just make FDA as an example, right? Before buying a product, or let's say makeup product or food product, but let's just go with makeup product since I am a girl. So before buying one, for example, this Maybelline Lippy. So before I bought this, I've checked first from the FDA if it is really FDA approved, because if not, it might contain ingredients which could harm me, because of course it is not FDA approved, right? And then another example, in terms of food, there are foods which are not FDA approved, right? Like for example, gamot or the medicine, like the one you bought on TikTok, like let's just say online platforms, are you sure that it is really FDA approved? So we must first check in their website, oh, is this really FDA approved? Oh, do I need to double check first? Because what if they said it na, oh, it's okay, you can buy this because this is FDA approved. But when you double check it, it's not FDA approved. So in short, they are scamming you. So let's just be mindful. So in the electronics, they have the IEEE and the ISO 901. So reliability, wait. Yes. Reliability Control System, or the RCS, is a framework designed to ensure that the system, whether mechanical or electrical, over a software-based function correctly and consistently over time. It involves strategies, methodologies, and technologies that help maintain system performance to minimize failure and enhance dependability, right? So, investigation of reliability alert. An investigation of reliability alert is a process conducted when a system, components, or operation triggers a reliability concern. These alerts typically indicates a potential issues that could lead to system failure, performances, degradation, or safety risk. So, does anyone have a question? Thank you. So, once again, I am Curly